Today we're going to talk about transformations in the coordinate plane. So to talk about transformations, we have to first start off by talking about what the transformation rules are. So we have four types of transformations: a translation, which is shifting it left, right, up, or down; a reflection, we'll talk about the different reflections, but you can reflect it across the x-axis, the y-axis, or on the line y equals x. You can rotate 90 degrees, 180 degrees, or 270 degrees. And a dilation is going to be working with a scale factor, which doesn't change the shape of what you're transforming, but it changes the size of what you're transforming. So let's start with translations. So in a translation, you take each coordinate point x, y, and you will either add or subtract a, or add or subtract b to either x or y. Now, a is going to shift it left or right, so plus a shifts it to the right, minus a shifts it to the left, and then b, the part that you add onto y, will shift it up or down. So plus b will shift it up, and minus b will shift it down. Next we have reflections. So a reflection in the x-axis will mean that each of those coordinate points x, y becomes x negative y. So x stays the same, but y becomes the opposite. In the y-axis, in this case, x becomes the opposite and y stays the same. And then in the line y equals x, you simply swap x and y. Now for rotations. A 90-degree rotation means that xy will become negative yx. 180-degree rotation means that both x and y become the opposite, so negative x, negative y. And 270 degrees, xy becomes y, negative x. All right, and lastly we have dilations. So when you have a dilation, you'll have to be working with some scale factor of k. Now, if k is bigger than 1, that means your transformation is going to become larger. If it's smaller than 1, then it's going to become smaller. So if you have x comma y, all you'll simply do is multiply both x and y by your scale factor k. Okay, let's take a look at example 1. Draw a dilation of rectangle ABCD on a coordinate plane, with A being 3, 1, B is 3, 2.5, C is 5, 2.5, and D is 5, 1. Use the origin as the center and use a scale factor of 2. Now generally with all the dilations we're going to be doing, you're going to be using the origin as the center. That's what the rule is telling you. So we're also told that the scale factor is 2. So the algebraic rule that we're going to use here is that xy becomes 2x, 2y. That means I multiply the x and y coordinates in each of those points by 2. So the pre-image, I'm going to list out the points and then give the new image. So 3, 1 becomes 6, 2. 3, 2.5 becomes 6, 5. 5, 2.5 becomes 10, 5. And 5, 1 becomes 10, 2. All right, so now let's go ahead and graph both the pre-image and the image. So we have 3, 1, that's A, 3, 2.5, that's B, 5, 2.5, that's C, and 5, 1, that's D. So that is the pre-image, the original image. And now we'll draw the image after the dilation. So now we have 6, 2, we have 6, 5, 10, 5, and 10, 2. And now you can see, comparing these two, that the original versus the image after the transformation shows that we have, in fact, applied a dilation with a scale factor of 2. All right, you'll also see some examples, like in this next one, where there may be multiple transformations. So here we see rectangle ABCD has vertices 2, 2, 6, 2, 6, 4, and 2, 4. Sketch ABCD and its image after a reflection in the x-axis and a rotation of 270 degrees. So there are two parts here. First, a reflection in the x-axis, and second, a rotation of 270 degrees. So let's start off by writing the algebraic rule. So first, we're going to do a reflection over the x-axis, so xy becomes x negative y. And then we will rotate this 270 degrees, so this will be y negative x. All right, so now let's go ahead and take each point and we will apply both of these transformations. So first we have 2, 2, which becomes 2, negative 2. And now your y coordinate comes first, so that becomes negative 2. And then your x coordinate becomes the negative, so that's negative 2. Next we have 6, 2. And we're going to make y the opposite, so that becomes 6, negative 2. And now we're going to change 6, negative 2 and make that y negative x, so that becomes negative 2, negative 6. All right, for C, we have 6, 4. That becomes 6, negative 4. And then rotating it 270 degrees, we get negative 4, negative 6. And then last we have 2, 4, which becomes 2, negative 4. And then negative 4, negative 2. Now when we're graphing, we're only going to graph the pre-image and the final image. So let's start with the pre-image. So 2, 2, 6, 2, 6, 4, and 2, 4. Okay, so there's that rectangle. And now after reflecting in the x-axis and rotating it 270 degrees, we have negative 2, negative 2, negative 2, negative 6, negative 4, negative 6, and negative 4, negative 2. Now you'll notice here that these two rectangles are identical to each other in that the size and the shape of it has not changed because we did not apply a dilation, but we did reflect it in the x-axis. So we took that green rectangle, we reflected it in the x-axis, and then we rotated it counterclockwise 270 degrees. So that's why we end up in the third quadrant there.